Section 3.5 is graphs of inequalities, and we're still going to graph everything the same we have in the old parent function section, except for now we're going to have to worry about shading and whether we have solid or dashed lines to graph with, and that's all going to be told by this inequality sign here. All right, so we're going to pretend like it's just we're going to graph it like it's an equal sign, um, and then we're going to shade. All right. Now the first thing I look at is going to be a solid or dashed line. It's going to be a solid line because it's less than or equal to. Because of that equal to, that means any point on the graph can be a solution to this problem. If it was just kind of like down here, if it's a greater than sign, it's saying anything bigger, but if it's equal to it, it's not a solution. Therefore, we have to graph it with a dashed line. So we know what the cube root graph looks like. It was in our parent graphs. And we know if it's inside the square root, it's going to move opposite the sign. So we're going to move um, left 2, and then it's going to move down 4. 1, 2, 3, 4 because of this negative 4 on the outside. Um, so this graph is actually, if you remember our x to the third power is a graph that came up and went along like that. Um, this graph is going to be the sideways of that. It's going to come down here and go something like that. Okay, and we said it was going to be a solid line. And then the only thing we have to do is pick a point and check your solution. So pick a point either above or below that line. If we pick a point either above or below it, it can't be on the line. We'll be able to tell what side we shade. I always pick, if possible, I pick 0, 0. If it's not on the graph, I pick 0, 0 because it's very easy to plug in 0 for x and y and get an answer. So I'm going to plug 0 in for y. 0 less than or equal to the cube root of 2 minus 4. The cube root of 2 is a really small number. Um, and then we're going to subtract 4. So we're going to have a negative number. The cube root of 4 or cube root of 2 is not going to be bigger than 4. We're going to have a negative number. So is this negative number, is that greater than 0? Is 0 less than or equal to a negative number? Well, no. So since that's false, we got to shade on the opposite side of it. Okay? Moving on to the next graph, y is greater than the absolute value of x plus 2 plus 4. Again, we know what the absolute value parent graph looks like. We know it's a V shape starting at 0, 0, right? It's the shape of a V, okay? The only thing that changes, this is going to have to be a dashed line because of this not greater than or equal to. And we're going to know that it's going to be translated. We're going to have to move it to the left 2 spots. 1, 2 to the left because inside we move opposite the sign. Outside we move up or down. So up 1, 2, 3, 4. So our point on V is at negative 2, 4. And it's a dashed line like this. All right, and it says greater than. Again, pick a point not on the graph. Again, I'm going to pick 0, 0 because it's a very easy point, and it's not on the graph. Is 0 greater than or equal to the absolute value of 2 plus 4? The absolute value of 2 is 2 plus 4 is 6. Is 0 greater than 6? Well, no. So outside of this graph is not shaded, but inside of this graph has to be shaded. Okay. Sorry about that. I had a student come in. We just got done graphing that equation, and we shaded in the inside because our statement, the point we picked, was false. So we're going to shade on the other side of the line of the point that we picked. All right. Moving on. Again, we have another absolute value problem. Let's see. It's telling us to solve the absolute value of x minus 2 is less than 1, or 0.1. I remember, actually, I teach algebra now, and I remember that we've solved this in algebra before. We know that an absolute value, inside of an absolute value, can be either negative or it can be positive. Anytime we have an absolute value problem, we need to solve two cases. We need to solve the x minus 2 is less than 0.1, and then we also need to solve the negative of that, which we flip this sign and change this guy's sign. So we have to solve x minus 2 is greater than, we switch that sign, negative 0.1. All right, so we have to solve two cases. And in order to solve this, we're just going to add 2. X has to be less than 2.1. and here we're going to add 2. X has to be greater than, um, that would be 1.9 when we add 2 to both sides here. So x has to be in between 1.9 and 2.1. Again, another way you can write it is you can sandwich the x's because we have a greater than. So I could say 1.9 has to be less than x, which would have to be less than 2.1. And the reason we can write that, if you read starting from the middle and going out, this is saying x is greater than 1.9. If we read to the left side, that's what this is saying. X is greater than 1.9. If you start in the middle and read to the right, this is saying x is less, a less than sign is less than 2.1, and that's exactly what we have. So x has to be somewhere in between those two values. All right. And so another problem that comes in application that we have, it's called the Top Machine Tool Company. It makes 3.75-inch diameter pistons for automobile engines. And in order for those pistons to work properly in each engine, the diameter of a piston can vary by no more than 0.0001 of an inch. All right, otherwise the piston won't fit into the engine. So they want us to write an inequality to represent the diameter of that piston. Well, let's think about this for a second. If I have a piston that's X big, right? If it's X amount of big and it's supposed to be 3.75 and it can't vary by more than this, all right? If we subtract 3.75 from my size of my piston, I should get hopefully a really small number such as this. And actually, if you read this, can vary by no more than gives you a hint that that is saying that it has to be less than or equal to 0.0001 inch. So we have what happens now is, would you agree that I could have a piston that would be smaller than 3.75, right? So what happens is we can go the absolute value of x minus 3.75 has to be less than or equal to 0.0001 inches. All right. And the reason for that was because, like I said, we could have a smaller piston than 3.75, and if we would subtract a smaller number from a bigger number, or sorry, if we would take a small number and subtract a bigger number, we get a negative. Well, obviously we can't have a negative size of a piston, so therefore we'll take the absolute value of that would make it positive. So what is the largest and smallest diameter allowable for that piston? Well, we're going to have to solve an absolute value inequality, which means we're going to have to solve two cases. We're going to have to solve the case where x is bigger than 3.75 is less than or equal to 0.0001. We're going to have to solve the case where it's smaller. So x minus 3.75 is going to be negative. So sorry, my bad. I had to change the sign. Let me erase it. It is going to be greater than or equal to 0.0001. All right, and we solve both of these by adding 3.75 to 0.0001, and we get, whoops, we have to get x is less than or equal to 3.7501. And then again, if we add, sorry, this is a negative out front here, sorry, we flip the sign, we add a negative to that. So x has to be greater than or equal to 3.7499. All right. So we know that our piston has to have a diameter that's in between those guys. So if we wanted to rewrite it, we could rewrite it as 3.7499 is less than or equal to x, which is less than or equal to 3.7501. And again, if we read that from the middle, this is saying x is greater than 3.7499. X is, and if we read to the right, x is less than 3.7501. So our x value has to be in between those. So I hope this helps, and we'll see you in class.